In previous videos, you've already learned how an array works in C#. An array is simply a list of items that are ordered, and they're ordered by the index that they're in. When you work with an array, you have to specify the data type and you have to specify the length, and then that length goes out and allocates that specific memory for that structure, and then you just have a variable that points to that structure. You can't resize that structure. You can't make it bigger, can't make it smaller. That's just the size of the structure. They're simple to use. You just access elements of the array through the index number. Arrays start at 0, and they're very fast because the memory is all allocated and it's contiguous, side by side. It's just right next to each other. Now the difference with that is, what if we had something that we wanted to work with that needed to grow or shrink depending on how we work with it? That's called an array list. And an array list is a dynamic array, meaning that it just resizes itself. When it fills up, it just makes more room. Really easier to use in an array, but they're not as fast and efficient as an array, because when they go to resize, they have to find another chunk of memory and work with it. I often call array list accordion arrays because they can grow and shrink. So let's go ahead and open up a new project and learn how these work. So I'll do a file, new project, and I'll just give it a name, ArrayList me. I seem to like to add the word me to everything. And it'll create our brand new project for us, and then we're going to start creating an array list. So here is the project, and if we wanted to make an array of something, we'd have to specify the data type, say that it's going to be an array, would give it a name, and then we'd go and actually say, yes, go make it a new array, and we would want to specify the size that we want to work with. Sorry about that, I added a constructor on the end of that. So this would say make an array called AI_nums of type int, and it's going to have 3 elements or 3 positions in it. And the indexes that you'd use to access those elements would be AI_nums bracket 0, and AI_nums bracket 1, and AI_nums bracket 2. That's an array. It's fixed in size, fixed in memory, and you have to specify the data type. Well, if I want to work with an array list, then it'll be a lot easier for us. First of all, array list is a type of collection. It's a type of collection. And so I would come in and I would say, let's go make an array list. And I'll give it a name. And then you just say new array list, and you call a constructor. Now, sorry, it tried to grab our name instead of the array list. So this is the data type. It's an array list. There's the variable name, new, the data type, constructor. Now, why does it still give me an error? If you click on this little light bulb, which means Visual Studio is trying to help you, click on the light bulb and it says, hey, if you want to work with an array list, you need to go and add something. You either need to go add this using systems collection or using system collections array list, because this is where the array list class lives. Arrays live in the collections generic, we could assume, but array list needs to be brought in. So I'm going to go ahead and click on using system collections. It adds this line, and now that class is visible. Now I can start working with that array. So first thing you need to remember is, if you want to work with an array list, you have to include the code for working with that class. Now that I have an array list called AL_numbers, it lives, but there's nothing in it. I don't have any elements. If I wanted to add an element to it, I would say the variable name dot, and then look at this. Since it's a variable, that variable is an object, and it has all of these methods associated with the array class. And one of the methods we can use is called add. And add says you can add something to an array. So I'm going to go ahead and add a number there. that now increases the size of the array, and it said you have a new element in it and it has a value of 45. I could print that off by simply saying AL numbers bracket 0, and that would print the value stored in that first position of the array. In fact, I'm going to go ahead and run this and let's see what happens. So we should see the number 45 show up when it runs the program for us. And there is the number 45 because we said add a new position to the array list and stick that value in it. Now this is interesting because if you notice, there's no data type associated with it. Does that mean I could now say AL numbers dot add parentheses Greg? That would be fairly odd to do, considering that an array says you have to specify the data type associated with it. Well, let's see what happens. Let's see if I can put an int and a string as elements in that array list. Sure enough, doesn't care. So that's very, very flexible and easy to use. The bad thing, though, is that working with that array list, it'll be slower than an array because it doesn't have the data type specified. There is no strongly typed value. So the system has to know how to work with it. The other thing is it could cause problems because let's say that we made an assumption that all of the elements in that array were actually integer values, and I said isum is equal to AL numbers bracket 0 plus AL numbers bracket 1, and we wanted to try to work with that. Well, this says we can't do that because that's really an object. Well, let's pull out some value. I guess we can't get a string. Maybe we could do a conversion, because even though we think that's just a number in there, it's really being treated like an object. So if I wanted to work with that number inside of there, I now have to go and do a convert to get to the data type, and now I can say convert that, let's store it to isum. Let's see what happens if we try to run that, because in the first position is 45, the second was Greg, and it says, hey, you can't do that. You can't convert Greg to an int and try to add it to something else. So array lists, even though they're very flexible to use, are not type safe. Type safe, meaning since we don't strongly type them, we don't make them an int or a string or whatever, and they all are the same data type, you could have a problem later on if you're not careful. So that's a disadvantage of working with an array list. Well, let's come in here and let's just add some other numbers to this array list. I'm going to pause the recording and I'll just add a bunch of numbers. So by doing this, I've now added 1, 2, 3, 4, 5, 6 elements to the array list. I'm going to go ahead and print something off about that array list, and it's called capacity. And let's go ahead and see what prints out capacity-wise if I have 6 elements in that array list. It says capacity is 8. Well, I wonder what that means. Well, let's go comment out everything except one of the elements. So we added one element to it. Let's run it again and see what the capacity is. Now the capacity is 4. Let's do it again. Let's take off all the elements in that array list so there's no elements. Run it one more time. Now the capacity is 0. So what does this mean? What it means is when you add an element to the array list, it automatically allocates enough room for 4 elements. Once I hit 3, let's see what happens if I do 3 and see what the capacity is. We're still at 4. What if I have 4 elements now in that array? So I've used up every block that it originally allocated. Now what happens? We're still okay because we haven't exceeded it. Okay, let's exceed the number of elements that it allocated, because it started by allocating 4 elements. Now we're at 5. Now it doubles that. So it took the 4 and it doubled it because it says, oh, it sounds like you're going to be doing work with this array list. We better make it a lot bigger because we're trying to be more efficient and help you. Well, what would happen if we had 10 elements to the array list? What would the capacity be? 16. Why? We did 4, we added number 5, it doubled 4 to 8. We then did 6 and 7 and 8, we added number 9, and it said, wow, you're really working with this a lot. Let's double it again. So now it allocates 16 spots for that array. And guess what would happen if I did all 16 and I added number 17? Then it would double it to 32. And if I did 33, it would double it to 64. So that could be a disadvantage of working with an array list also. It's trying to be smart and be more efficient, but it doesn't work with memory very well. Now that I have, let's go back to just our 5 that we have, and we'll uncomment that. There's our numbers of the array list. That's what the capacity line does for you. Another one that we can do to see information about that array is called count. So let's go ahead and run that and see what we see, what shows up. 6. So count simply tells you that's how many elements in the array list. It's similar to length in an array. Let's go ahead and try something. Let's print off all of those elements. I'm going to go ahead and use a for each, because a for each is a loop that works with collection objects, meaning one or more of the objects. An array is a collection object. An array list is a collection object, and the syntax is you specify the data type you want to work with. We're going to hope that it's int, but remember it's not type safe. Specify some name that you want to work with. That just means create a variable called inum of int, and then we say in the collection itself. Here's our collection, and this is a variable of type int we want to use. And so what that for each is going to do for us is it's going to say for every single element in that collection, one at a time, it's going to pull the value out of there just as a copy. It doesn't destroy it. It copies the value out of the first element, puts it into there, I print it off. Get the next one, put it into there, print it off. The next one, print it off. The next one, print it off, and so forth until there are no more elements. I could have also written a for loop to do that and used the count of the array list for int iCount equals 0 as long as iCount is less than the array list dot count iCount plus plus. You've seen that in other videos on how to use a for loop working with an array. Same thing works with an array list, but the for each is pretty nice because it actually handles a lot of that as long as you're working with a collection object, and that is a collection object. So this should print off every element of the array list. Let's see if that works. And there it is, prints them all out. Let's do it again, but now that I've printed them all out once, I want to say AL numbers dot sort, and that's a method. So we do a method call, and then I want to copy this code and print it all again. I want to go ahead and also separate this with some blank lines so we can see where the break actually happens. So we said print off all the elements, now go sort it and print them again. Let's see what happens. There's the original list, and then remember this is capacity, or this is the count, and then it sorts it and then prints it off again. So that's pretty nice. You can just say sort and it would print it off. Let's do it again. This time let's say AL numbers dot reverse parenthesis parenthesis, and we'll print that again. And I want my console.writeLine in there so I can see where the break occurs. So now we should see the original list, the sorted list in ascending order, and the sorted list in descending order. So that's something really nice about working with ArrayList, is we can just call methods to work with it. So far in this video, you've seen that when you create an array list, you don't specify the data type. You just say ArrayList, new, and call a constructor. The add method allows you to add values to the array list. You also saw that the array list values don't have to be the same data type, but that could cause problems. you saw that capacity is just showing how it allocates memory for the array list as it grows. It starts at 4, doubles to 8, doubles to 16, doubles to 32. Count tells you how many members are in it. The for each is great for working with it since it's a collection and it will pull one element at a time. You also saw that you could access each element simply by specifying the array list name and a position, and that would print it out. You also saw that if you wanted to do anything with those values, like add them to other values, then you're going to have to cast them to be whatever data type they are. For instance, that would turn it into a number. Or you could do a toString parenthesis, and that would turn it into a string. You've also seen the sort method sorts it in ascending order, and the reverse sorts it in descending order. This is part 1 of ArrayList, and let's move on to part 2.